All right, so get ready to have your minds blown wide open because today we are diving headfirst into the world of quantum computing.
Sounds exciting.
Oh, it is. We've got
Yeah.
some really incredible research papers and book chapters to unpack here.
Yeah.
And our mission, if you choose to accept it, is to help you really understand the core ideas of this technology, what's happening right now in the field,
Right.
and maybe even glimpse the unbelievable possibilities and challenges, of course, that quantum computing brings to the table.
Yeah, it's a truly revolutionary technology with a huge potential.
I mean, we're talking applications that could completely change how we design new drugs, maybe even crack the codes that keep our online world secure.
Hmm.
Like, this is not science fiction anymore. This is happening.
It is. It is.
Okay, so first things first, can we just take a second to geek out about qubits?
Of course. Of course.
I mean, come on, the idea that these things can be 0, 1, or both at the same time, that just fries my circuits.
I know, right? It's wild. It's this really core concept called superposition.
Superposition, okay.
And it's one of the things that makes quantum computing so powerful.
I see, I see.
So think about a coin spinning in the air
Okay.
until it lands. It's not heads or tails. It's kind of like a fuzzy mix of both, right?
Yeah.
It's kind of like a qubit in superposition.
Ah, so it's like it's in this weird in-between state
That's how it's measured, yeah.
until someone forces it to choose.
Exactly, yeah. And then, on top of that, you have this other crazy thing called entanglement.
Okay, entanglement. Lay it on me.
So this is where you get two of these qubits, and they become linked together.
Hmm.
It's kind of like if you have those two spinning coins, right?
Mhm.
And when one lands on heads, the other one instantly flips to tails no matter how far apart they are.
Ah, okay, that's mind-boggling. How is that even possible?
It's quantum mechanics. It's a different set of rules than what we're used to.
Okay, but how does all of this actually translate into, solving problems? Like, does it really give these quantum computers some kind of superpower?
Well, think about it like this. Let's say you have a maze, right?
Mm-hmm.
And you want to find the way out.
Mm-hmm.
A classical computer, the kind we use every day, would try each path one by one.
Right.
But a quantum computer, using superposition, it can explore every path simultaneously.
Whoa, wait a minute. So it's like it's cheating at the universe's toughest problems.
In a way, yes. It's not just about speed. It's a completely different way of thinking about information.
Okay, so that leads perfectly into my next question. Let's talk about the timeline of this whole quantum revolution.
Sure.
How long have we been working on this stuff? And are we talking about theoretical pipe dreams here, or are there actual quantum computers out there doing things?
Well, believe it or not, we've actually been on this journey for quite a while. The early theoretical groundwork that was laid back in the early 20th century with the development of quantum mechanics.
Oh, wow, so this is not a new idea.
Not at all. But the real push towards building actual quantum computers, that started around the 1980s.
Okay.
And things have really accelerated in recent years.
So it's been like the slow burn that suddenly caught fire?
Yeah, you could say that.
And so you're telling me there are real quantum computers out there right now?
Absolutely. Built by companies like Google, IBM, Rigetti. They're all in the game.
Wow, so it's really not science fiction anymore.
No, not at all. In
Huh.
fact, back in 2019, Google made headlines because their quantum computer, Sycamore, achieved what they called quantum supremacy.
Hold on, quantum supremacy, what does that even mean?
It means that Sycamore solved a problem faster than any classical computer on Earth could.
Really?
Yeah, this is a very specific problem, but still, it was a major milestone.
Okay, I'm impressed, I gotta admit. So can anyone just like buy one of these quantum computers and start playing around with it, or is it like super exclusive?
Well, you can't quite order one on Amazon just yet, but
Right.
companies like IBM, they offer cloud-based access to their quantum computers.
What does that mean?
So it means that researchers, developers, even just curious people, they can actually go online and experiment with quantum algorithms, run their own programs.
So the quantum revolution is becoming more accessible. That's really cool.
It is. It is.
Okay, so now let's talk about the really exciting part, the applications.
Yeah.
Where could this technology actually make the biggest difference in the real world?
Well, one area where it holds tremendous promise is healthcare, specifically in drug discovery.
Ooh, okay.
Imagine being able to design and test new drugs virtually with incredible precision, all thanks to quantum simulations.
So instead of spending years and years in a lab,
Yeah.
scientists could create like life-saving medications much faster.
Exactly. There's actually an incredible example with the development of ibrutinib. It's a cancer drug. This problem, it would have taken a classical computer 1,000 years to solve.
1,000 years?
Yeah, 1,000 years. But using a quantum approach, something called rare qubitization, it could potentially be done in just over a week.
Oh my God, from 1,000 years to a week.
I know.
That is a game changer.
Absolutely.
And it's not just about drug discovery, right? What about things like personalized medicine, where treatments are tailored to an individual's genes and all that?
Absolutely. The precision of quantum simulations could completely revolutionize personalized medicine as well.
Okay, so it sounds like quantum computing could totally change how we approach health and disease.
Yeah.
But what about other industries? Where else could we see this kind of dramatic impact?
Finance is another area that's ripe for disruption.
Okay, how so?
Well, think about it. Quantum computers could analyze risk, optimize investment portfolios, even predict market trends, with a level of speed and accuracy that would leave even the best financial analysts in the dust.
So it's like having a crystal ball for the stock market.
You could say that.
Sign me up. But on a more serious note, isn't there also a lot of concern about these quantum computers, cracking the codes that keep our digital world safe?
That's a valid concern.
Hmm.
A lot of our encryption systems, they rely on the fact that it's really hard to factor large numbers, something that theoretically quantum computers could do very quickly. So, yeah, that's why there's a big push to develop what they call quantum-resistant encryption methods.
Right, so we can stay ahead of the game.
Exactly.
So it's kind of a double-edged sword. Solving problems we never could before, but also maybe creating new ones that we have to figure out.
Yeah, it's a new frontier.
Beyond finance, where else could this speed and precision really revolutionize things?
Think about industrial automation, for example.
Okay, like factories and stuff?
Exactly. Quantum computers could optimize every single aspect of a factory,
Wow.
from managing supply chains and production processes to ensuring top-notch quality control.
So we're talking about factories of the future running at peak efficiency, all thanks to quantum computers making all the decisions.
It's a very real possibility. Imagine self-adjusting supply chains that perfectly anticipate demand, predictive maintenance that can spot problems before they even happen,
Yeah.
and quality control that's practically flawless.
That's amazing. But before we get too carried away with all this incredible potential, let's not forget that this technology is still very young.
Right.
What are some of the big hurdles we still have to overcome?
Well, one of the biggest challenges is the hardware itself.
Okay.
Qubits, those magical things we were talking about.
Mm-hmm.
They're incredibly sensitive to their environment and prone to errors.
So it's
It's like trying to balance a stack of coins on edge during an earthquake.
Whoa, that's a really good analogy. So it's this delicate dance between pushing the limits of what's possible while also trying to keep these qubits happy.
That's exactly it.
Oh.
And then on top of that, we also need to develop completely new ways of thinking to even program these machines.
Yeah, that makes sense. It's like learning a whole new language.
It is. It's a whole new language of computation.
So it seems like we're still in the early chapters of this whole quantum story.
We are.
But I'm already hooked. What's next on the agenda for our deep dive?
Well, next up, we're going to explore how quantum computing could turbocharge another really exciting technology, artificial intelligence.
Ooh, okay. AI is already transforming the world as we know it, so imagine what happens when we add quantum power to the mix.
It's a powerful synergy with a lot of potential, that's for sure.
I can't wait to hear more about it.
We'll dig into all the details right after this.
Sounds good.
Welcome back. So before we took a little break there, we were talking about all the potential of quantum computing.
All the potential, yeah.
And now we're going to shift gears a bit and look at how it could really supercharge another technology that's already, making waves. Artificial intelligence.
Okay, now you've got my attention. I mean, AI is everywhere these days, right?
Yeah.
Self-driving cars, those movie recommendations that are a little too good.
Yeah, exactly.
So how does quantum computing actually take AI to a whole new level? Like, what's the secret sauce?
It really comes down to the algorithms. You see, quantum algorithms, they have this potential to just supercharge machine learning in ways that are just not possible with our regular classical computers. We're talking about, training AI models way faster, making their predictions even more accurate, and even tackling problems that are just impossible for even the most powerful computers we have today.
So we're not just talking about like small improvements here.
No.
This is like quantum computing could unlock entirely new possibilities for AI, right?
Absolutely. That's the really exciting part. Like, Take, for example, quantum support vector machines, or QSVM for short.
QSVM, okay, gotta love a good acronym. So what are those?
So these are like, imagine the support vector machines we use today in machine learning, but supercharged.
Okay.
And they're really, really good at classifying data, even when you have these incredibly complex data sets.
Okay, back up a second. When you say complex data sets, what do you actually mean? Like, paint me a picture.
Okay, so imagine you're trying to find patterns in data that have like thousands, maybe even millions of variables.
Mm-hmm.
It's like trying to find a single grain of sand on a beach,
Yeah,
right?
that sounds tough.
Our classical algorithms, they can get totally lost in all that complexity. But QSVMs, they can just slice through the noise and find those patterns with incredible accuracy.
Wow, that's pretty amazing. So it's like having a quantum magnifying glass for data analysis. Are there other, like, quantum machine learning tools out there? What else can we do with this stuff?
Oh yeah, there's tons of cool stuff happening. Another really exciting area is generative AI, specifically quantum generative adversarial networks, or QGNs.
QGNNs, all right, another acronym for the collection. Generative AI, now that's something I've heard a lot about lately. What makes these QGNNs so special?
Well, think about the GANs we have today, the ones that are creating those realistic images, music, even writing text.
Right, right.
QGNs are like the quantum version, but with the potential to push things even further.
Wait, hold on. So you're saying we're talking about AI that could create art and music that's like indistinguishable from what a human could make?
It's definitely within the realm of possibility, which, raises all sorts of interesting questions about, like, what does it mean to be creative? What does it mean to be human?
Yeah, it's a little unsettling, honestly, but it also just shows how powerful this technology really is.
Exactly. And then beyond QSVMs and QGNs, there are also things like quantum neural networks.
Oh, wow. Okay, so many possibilities. What can we do with quantum neural networks?
Well, they're still pretty early in development, but they hold a lot of promise for things like pattern recognition, image classification, even natural language processing.
So we could be looking at AI that can actually understand and respond to human language. Like, imagine the possibilities. Instant translation, voice assistants that actually get you, maybe even AI that can write poetry that actually makes you feel something.
All of those are possibilities, and it's pretty exciting to think about how quantum computing could accelerate progress in all of those areas.
Yeah, it's mind-blowing stuff, no doubt. But I gotta ask, is there a downside to all of this? I mean, quantum machine learning, it can't be all sunshine and roses, right? There's gotta be some challenges.
Well, yeah, of course there are challenges. I mean, one of the biggest ones right now is just access to quantum computers.
Okay, so they're still, like, really rare and expensive.
Exactly. And that limits, who can actually experiment with these algorithms and actually develop them further.
So it's like having $1 million race car, but no racetrack to actually drive it on.
That's a perfect analogy. And on top of that, we also need to keep developing better algorithms, ones that can really, truly take advantage of the power that quantum computers have.
Right. It's not just about the hardware, it's about the software, too.
Exactly. Having the hardware is just the first step. We need the right software to really make it sing.
It makes sense. It's a whole new way of thinking about computation, right?
It is. It is.
It seems like we're still in the early stages of quantum machine learning, but the potential is pretty enormous.
Oh, absolutely. This field has the potential to revolutionize so many things, from how we diagnose and treat diseases to how we understand the universe itself.
It's a wild, wild world we're stepping into. Okay, so I'm ready for more. Let's switch gears a bit and talk about the evolution of quantum computing itself.
Okay, sounds good.
What were some of the big milestones, the big aha moments that got us to where we are today?
Well, as we touched on earlier, the journey really began in the early 20th century with the birth of quantum mechanics.
Right.
There was a time of, like, radical new ideas. You had physicists like Max Planck, Albert Einstein, Niels Bohr.
The big names.
Yeah, the giants. They were challenging everything we thought we knew about the universe.
So we're talking about a time when the very foundations of physics were being rewritten.
Exactly. It must have been an amazing time to be a scientist, exciting, but maybe a little terrifying too.
Yeah, I can imagine.
It was a period of just immense intellectual, like, ferment. But all of those early insights into the weird world of quantum mechanics, that's what laid the foundation for everything that came after.
I see, I see. So then when did people start thinking, hey, maybe we can actually build computers based on these weird quantum rules?
Well, that started to happen in the 1980s,
Okay.
almost 50 years after those early quantum discoveries.
Wow. So it took a while for the idea to catch on.
It did, but one of the real pioneers was this brilliant physicist, Richard Feynman.
Okay, Feynman, yeah.
He realized that our regular computers, they just couldn't handle the complexity of simulating quantum systems.
Right.
And so he proposed, hey, why don't we build computers that use quantum principles themselves?
That's some serious vision right there. What happened next? Was it like a straight shot from Feynman's ideas to the quantum computers we have today?
Not quite. It was a much more gradual process, building on those early ideas, lots of experiments, probably a lot of dead ends along the way.
Yeah, that makes sense.
But then, in 1994, this mathematician named Peter Shor, he dropped a bombshell.
Ooh, a bombshell. I like bombshells. What was it?
He came up with an algorithm
Okay.
that could factor large numbers exponentially faster on a quantum computer than on a classical computer.
Okay, I gotta admit, math is not my strong suit. So why was this such a big deal?
Because a lot of our online security, things like banking transactions, secure communications, even national secrets, they rely on the fact that it's really, really hard to factor large numbers.
Right.
Shor's algorithm showed that a quantum computer, theoretically, could just crack those codes wide open.
Oh, wow, that changes everything.
It did. It was a wake-up call, like suddenly realizing that the locks on your doors are made of paper.
Exactly. So what happened? Did everyone panic and start scrambling to build quantum-proof defenses?
There was definitely a sense of urgency, yeah. The discovery of Shor's algorithm basically kickstarted a global race to build practical quantum computers.
It's like the space race, but for quantum computers.
Yeah, kinda. Companies like IBM, Google, Microsoft, they all poured tons of resources into the field, and that's when we started seeing those first experimental machines emerge.
And that brings us to today, right? With Google achieving quantum supremacy and all that.
Right, but like we've been talking about, the technology is still in its early stages.
Right. Those pesky qubits.
Exactly. Building large-scale quantum computers that are also fault-tolerant, that's still one of the biggest challenges we face. Qubits, they're so sensitive.
Yeah.
Just maintaining their fragile quantum states, it's a massive engineering hurdle, like trying to build a house of cards on a vibrating table.
Oh, man, I can't even imagine.
And then, even when we do have the hardware, right, we still need to figure out the software, the algorithms that can really unlock the true power of quantum computing.
So it's a two-pronged challenge.
Exactly. Better, more stable hardware, and then a whole new way of writing code.
And let's not forget all those ethical and societal implications we touched on earlier.
Oh, right, absolutely. Things like data privacy, job displacement, the potential for misuse. There's a lot to consider.
It's a lot to consider. We're talking about a technology that could literally rewrite the rules of computing, maybe even reshape our whole world in ways we can't even imagine yet.
It's a revolution in the making, that's for sure.
Well, I'm definitely on the edge of my seat. What else is on our quantum adventure today? What other mind-blowing stuff do you have in store for us?
Well, let's take a moment to explore some of the more speculative, but still really intriguing possibilities of this technology. The really big questions, you know?
Okay, I'm all ears. Hit me with the mind-blowing stuff.
Yeah.
So we've talked about like all this incredible potential of quantum computing, right?
Yeah.
Revolutionizing medicine, finance, even AI.
Yeah, it's pretty wild stuff.
But I got to ask about, the really big questions, the ones that keep like philosophers and scientists up all night.
Oh, you're talking about the big mysteries, the intersection of quantum mechanics and consciousness?
Exactly. I mean, if these quantum computers can simulate molecules with like perfect precision, yeah, could they one day simulate something as complex as the human brain? Like, is that even possible?
Oh, that's a fascinating question. And it's one that's sparked a lot of debate, among experts.
Right.
Some people believe that consciousness, it's really just a product of like these complex biological processes, right? Neurons firing, synapses connecting, all of that
The
stuff.
whole brain doing its thing.
Yeah, exactly. And so they argue that if you had a powerful enough computer, even a quantum one, you could theoretically replicate it.
So basically, consciousness is like a really complicated equation that we just need a powerful enough computer to solve.
In a way, yeah, that's one way to think
Right.
about it. But then there are others who think, maybe consciousness is something more.
More.
Yeah, like maybe it's something more fundamental, maybe even tied to like the fabric of quantum mechanics itself.
Okay, now that's a mind-blowing idea. So you're saying our thoughts, our feelings could be like entangled with the universe at a quantum level.
It's a possibility that some physicists and philosophers are really starting to explore, yeah. They point to the fact that, quantum mechanics, it's inherently probabilistic, right?
Probabilistic, meaning
Meaning that things aren't like predetermined, but rather exist in this superposition of possibility
Right, right. We talked about that.
until they're measured.
Okay, I'm following. So are they saying that, like, consciousness is the observer that collapses those possibilities into the reality we experience? Like, we choose our own reality.
That's one interpretation, yeah. I know, it's a lot to wrap your head around.
It really is.
But it's fascinating to think that, maybe consciousness plays a more active role in shaping reality than we thought.
Whoa. It makes you wonder if we're all just walking quantum computers, constantly collapsing wave functions with every thought and decision.
I know, right? It's
Yeah.
wild. And it just highlights how, quantum computing is really pushing us to confront these questions that we used to think were just, like, philosophical.
Right, right. But it sounds like we're still a long way from having any real answers.
Yeah, for sure. Whether quantum computers will ever truly be able to simulate consciousness, that's still a big open question.
It is. It is. But even the fact that we're asking these questions now, that just shows how much quantum computing is changing how we think about the world.
It's expanding the horizons of human inquiry, that's for sure.
Yeah. It's exciting and kind of scary at the same time, honestly.
Yeah, I get that. I mean, we're talking about a technology that could completely change our world in ways we can't even begin to imagine. And like any powerful technology, it comes with potential for both good and bad.
A double-edged sword, for sure.
Yeah.
So it sounds like we need to have some serious conversations about, the ethics of this technology.
Absolutely. We have to be mindful of the risks, but also embrace the incredible opportunities that it offers.
Right. I mean, quantum computing could potentially help us solve some of humanity's biggest challenges, right? Like climate change, disease, poverty.
Exactly. It's a powerful tool, and it's really up to us to use it wisely.
Well said. Well, I gotta say, this deep dive has left me with way more questions than answers.
That's how it usually goes.
But that's a good thing, right?
Ah,
It sparked this curiosity in me to, like, learn more, keep exploring this whole quantum world and what it all means.
that's exactly what we hope for, to inspire our listeners to keep asking those big questions, keep digging deeper, never stop learning.
Well, I think that's a perfect note to end on. To everyone listening, keep those minds open, stay curious, and who knows, maybe one of you will be the one to unlock the next big quantum breakthrough. Until next time, folks, keep exploring the wonders of the universe, big and small.